Hey guys, welcome back to another math video. Today we're going to be doing this question from ACJC 2016 Prelim Paper 1, Question 1. Although it's the first question and it's usually known to be the easiest question out of the entire paper, it is actually quite interesting, so I'm going to check it out. But first, my mic quality should have improved by a lot. This is because I stole my school's microphone, so I hope they don't figure it out. So this question starts off as a very typical inequalities question, and it evolves into something that actually has to make use of your trigo in your secondary school. So let's check it out. So first question, without using a calculator, solve the inequality 2w minus 5 over w squared minus 3 is more than 0. So since the question says that we cannot use a calculator, we can't sketch the graph. So we have to use an algebraic method. So it's quite simple. All we need to do is we need to just find the critical points of critical values, do the sign test. So let's do that. So if I see 2w minus 5 over w squared minus 3 is less than 0, in normal circumstances, we wouldn't be able to factorize the denominator. But in this case, we actually do have to do that. So recall that if, for those who don't know, w squared minus 3 is the exact same thing as w squared minus 3 can actually just be expressed as square root 3 by you square it. So we're going to make use of that and going to use the difference of squares formula, which if you didn't, it's just a squared minus b squared. So if I sub this into here, 2w minus 5 over, then this will be w minus square root 3 w plus square root 3 less than more than 0. So once we're here, we can do the sign test. For those who actually don't know, which if you're watching this, I hope you know, the sign test basically tells us, which basically helps us to easily identify which regions do we want. Because normally, if you want to solve quadratic inequalities, which your secondary school has taught you, you have to draw the graph and then do that. But you don't actually need to do that. So if I draw the number line out here, the critical points are square root 3, negative square root 3, and 5 over 2. So in order, I have to label them in ascending order. So it's going to be negative square root 3, positive square root 3, and 5 over 2. They don't need to be accurately spaced out. But one more detail we are missing is that because square root 3 and negative square root 3 are in the denominator, they cannot, the x value or the w value cannot actually be plus or minus square root 3. Because if you remember in your graphing techniques, that's actually where a vertical asymptote is. And the graph never passes through the vertical asymptote. So you have to add a hollow circle just to tell you yourself and also the examiner that, hey, my w can never actually be these two values. So after that, what you want to do, if you were to do this, you would plug in a value, any value, besides of course this and this, and see what sign this expression will be. So if you were to do that, normally if I do that, I will do w equals to 10 or x equals to 10. You will find out that this is actually positive. Okay, it will alternate. So the question is asking us, what values of w will I get when I know that this expression is more than 0? Which means I'm looking for when it's positive. So actually, I'm looking for this region and this region. So my answer will be that w is, first of all, in between here and here. That is one possible outcome. Or another possible outcome is if my w is actually more than 5 over 2. So w more than 5 over 2. And this is the answer. So first part is worth 2 marks. I would say it's a pretty standard question. It's just testing you on if you even know what this chapter is. Okay, so let's move on to the second part. Okay, so the second part, hence solve 2 modulus y minus 5 times sine x over y squared minus 3 is less than or equal to 0, given that x is in between pi and 3 pi over 2. First of all, there are immediately two main problems that you find with the hence part. First of all, there is somehow a sine x over here. Okay, never mind. Second thing is that the inequality has changed to a less than or equal to. Now, actually this is a hint given to us that the sine x has something to do with making the inequality become like that. So, but first let's analyze this. Why is there a sine x? And do we need to do anything with the x? Actually, we don't have to. The question gives us a hint also that x is in between pi and 3 pi over 2. Now, let's go back to secondary school for a bit. Your sine, if I draw the diagram, your ASTC, your sine x is only positive in the first and second quadrant. But let's take a look at the range. Your x is in between pi and 3 pi over 2, not including pi, which means that if you don't know, for those who don't know, this is actually your pi. This pi is your pi. Or I wouldn't say this pi is like, if I were to draw a thing, this pi is pi. Then 3 pi over 2 is actually, if I keep going, this pi is 3 pi over 2. Hi, editor me here. Just to clarify, I meant that the angle of the thing was pi radians and 3 pi over 2 radians, not the length of the thing. Yeah. So it's actually saying that my x value is in the third quadrant, meaning that my x is negative. My sine x is negative, always negative. But if you're not convinced, let's convert this to a degree notation so that maybe it's easier for you to visualize. So pi, we know obviously is 180 degrees because radians, 360 is 2 pi, so which means pi is 180. 3 pi over 2, you can just do 3 over 2 times 180, which we will get 270 degrees. So once we have this, we know that x is definitely in the third quadrant, which only tangent is positive, meaning that my sine x is actually going to be negative. So then you might be thinking, how does this help us in finding our, or in this case our y? It doesn't seem to do anything, right? Well, in fact, this is actually the key thing that we need to, that the examiner actually wants the students to get in order to get the answer of this. What do I mean? Now let me clean this up first of all. Okay, so once we have this, we know that my sine x is negative, which means that first of all, to make it clearer, I'm going to separate the sine x. Because technically this is a multiplication, I can bring the sine x as like a coefficient. So I will write down sine x, and then I will put a big bracket, 2 modulus y minus 5 over y squared minus 3 is less than or equal to 0. We know that my sine x is negative, so I will show the examiner that I know what I'm doing, because I say since given that pi is less than x is less than or equal to 3 pi over 2, I'm just writing down the given information. My sine x will be negative. It is not less than or equal to 0 because we know that it is excluding pi, which means that my sine x is negative. So what I'm going to do now is, in order to simplify this expression, we can actually divide both sides by sine x. We don't need to worry about things. First of all, we know the sign of sine x, meaning that we don't need to worry, we don't need to consider two cases. Secondly, we also don't need to worry about dividing by 0 because we've already stated that sine x is going to be less than 0. Meaning we can just simply divide both sides by sine x. But if we divide both sides by sine x, we are dividing by a negative number, meaning that we need to flip the sign. So this expression is just going to be 2 modulus y minus 5 over y squared minus 3. Divide both sides by sine x, invert the sign, more than or equal to 0. So from here, can you see a resemblance to this? Yes, you can. So the only difference, and this is where your normal hence questions come in. Normally you would just replace the variable in here with another expression and then solve your that inside. So in this case, you have to replace our w with a modulus y, because this y square is just the same thing as modulus y square. Why? Because y square will always churn out a positive number. Modulus y is a positive, and you square it, you will still get a positive number. So once you replace it, we can actually just copy and paste our solution, which I've actually written here, to the first part. This one remains the same. So we will write modulus, we will write negative square root 3 less than modulus y less than positive square root 3. But this changes a bit, because why? The first part lets us do a more than 0. But this question is a more than or equal to 0. The reason why we didn't need to change the notation here, the reason why we didn't need to add a equal to, is because remember, my modulus y cannot be equal to square root 3, because otherwise this denominator will be 0 and it will be undefined. So I only need to consider if it's in between exclusive of square root 3 and negative square root 3. Or my modulus y is going to be more than, but since we can include 5 over 2, more than or equal to 5 over 2. Now the more experienced ones may see this and immediately know what's the answer, which the answer is 5 over 2 is y is less than that, or y is more than 5 over 2. But for the sake of those who may not be so good at visualizing, I will explain it step by step as to how to get to this step. So first of all, let me consider, I completely forgot about this case. Let's consider this case. Now, let me break this down. So I'm going to again clean things up, and I'll only leave it with this. Okay, so I've separated the two cases that we're going to look at. Let's take a look at this one first. So we can actually split this inequality into two parts. So let's do that. So this will be y is technically more than negative square root 3, but instead of an or, we put an n, because in this case the modulus y is actually satisfying both conditions. And modulus y is less than square root 3. Now, if we take a look at this, modulus of y is more than negative square root 3. It seems a bit weird, right? You're saying that you want to find the values of y in which if you take modulus of it, it will be more than a negative number. But isn't the condition for a modulus to be always positive? Well, let's try and visualize this using the graph. If I draw the graph of y equals to modulus x, which in fact I'll be using for this as well. If I also draw the graph, this is y equals to negative modulus 3, you will see that actually in fact the graph will always be, the graph of modulus x will always be more than the graph of y equals to negative square root 3. So what does this mean? It means that actually my y, actually this inequality doesn't really help us at all. Because what we are saying when we are doing this inequality, where next modulus y is in between negative square root 3 and positive square root 3, is we are seeing what conditions must y have, or what inequality must y have. In this case, and we are breaking them down into two parts, one where we tackle the negative part and one where we tackle the positive part. The negative part doesn't help us at all. So because why? Actually, from here I can conclude that my y just has to be a real number for this condition to be satisfied, for my modulus y to be more than negative square root 3. So using this alone, it will not help us at all. So we have to consider the second part, where modulus of y is less than square root 3. So how do we do this? Again, let's use this graph. I will now draw the graph of y equals to square root 3. We see that 1, the graph cuts the line, or the v shape cuts the line at 2 points. Number 2, we definitely seem to get an answer. So to help us, I will shade the region so it will be this entire part. Don't do this in your actual, if the question asks you to sketch the graph, don't do that, because the examiner might think that's your answer, that's part of your answer to the sketching of the graph. Then they will know whether to mark it right or wrong. So only do this if you have any rough work. So, but in this case, you can clearly see that if I want my modulus graph to be below my y equals to square root 3, is in between these two values. And this is where the two points will intersect, the two graphs will intersect. This point of intersection has coordinates of -3, square root 3, because if you think about it, when my modulus of something is square root 3, that something could be plus or minus square root 3. So then over here, it will be square root 3, square root 3. But since we only care about the x values, my answer for this is that, well, actually it's just this. It's just that we replace the modulus y with positive, with just a y. So my answer will be negative square root 3 is less than y is less than square root 3. So that's, but we're not done. This is part of the answer. Now let's move on to this. This will be a lot more simpler. Again, let me draw the graph of y equals to modulus x. I'm using x as the variable here, but remember that we're actually doing with y, meaning that don't think of the y value here, think of it as the variable here. So now let me draw the graph of y equals to 5/2. I know it's not drawn to scale, but the point is, if you know that, okay, this is a positive number, it means you will cut the graph twice. That's all you need to know. So now the question wants us to do more than or equal to 5/2, which is actually beyond this area. So again, we're actually finding the point of intersection between the straight line and the V shape. So let's do that again. This will be -5/2, 5/2. This is 5/2 and 5/2. So from the graph, we can see that or in this case, our y value is actually extending to the left of this point of intersection, meaning that it's going to be getting more and more negative, meaning that my y is less than or equal to -5/2, and there's another case where it's extending to the right of this point of intersection, meaning that my y can also be more than or equal to 5/2. Okay, so I have solved both cases and I have gotten conclusive results from them, meaning that my final answer, let me write it here. My final answer to this second part is going to be this condition where y is in between negative square root 3 and positive square root 3, or y is less than or equal to -5/2, or y is more than or equal to 5/2. And this is the final answer to this question. Cool. So yes, that's it for today's video. I hope you guys enjoyed it. If you guys did, make sure to give this video a like rating. If you really enjoyed it, make sure to subscribe to this channel. If you're new, I will hopefully do more math content over the coming June holidays. And yeah, that's it. See you guys in the next video. Bye bye.